this is really a dialogue, right? For this conversation, I did prepare a few slides kind of to walk you through some of the things I think may be important, in the spirit of what the Jill mentioned, right? To foster collaboration and also to give you some background of different things. For myself, I think it's a kind of we can, if you want to know more about my like a past career and experience, I'm happy to chat. Feel free to send me emails, and I always like to have this in-person conversations. And because of this large audience here, I think I will just go straight to some of the topics I think will be relevant for the collaborations. And so again, even though I prepare some slides, right? Again, I want to make sure that everyone kind of get something out of this dialogue, but feel free to interrupt me with any questions, okay? And we can discuss along the way. And it doesn't have to be finished all the presentations. And so it's really a free form, right? And Jill and I talked yesterday, so hey, we anticipate what kind of format will be the best. I think just let the flow, take us whatever it is, okay? So this is kind of a topic about AI for health science research and what are the opportunities at the UB and some of the activities we have right now, and I think what we can go forward. And so very quickly, right? So this is an institute. I think some of you know this already, but not all knows about this one. This is the UB's internal institute for artificial intelligence and data science, and called IAD. And this organization, actually, it is a relatively new organization within UB because we do have the Institute for AI and Institute for Data Sciences before, but it was mainly focused on educational aspect. And so recently, about a year and 2 years ago, starting to have this merge of these two institutes within UB become this IAD. And still, like a lot of the focus was on the education, and but gradually, right, and from the leadership team and also from the affiliated faculties, everyone felt we need to move this institute to the more research focus. And so I was starting to get involved at the like a year ago, and I formally took over this institute like November of last year. So this is the IAD, right? This is the institute at the UB, and it's funded through the VPR's office. And the goal of this institute, from the research perspective, is really to become the bridge, between different decanal units, and to foster collaboration, and to see how AI and data science can help you to transform your research and to make your research and to be the leading edge. And so there's also a affiliated faculty program, and you can apply for. And I encourage you, like if you click the info for, right, and under the faculty, you will see the link, and feel free to check it out. And if you're interested in to get to know more about this program, and feel free to send me emails afterwards as well. And so let me kind of give you a little bit of motivations of why we think this institute and should be focused on more of the research and what kind of role we can play, right? And I know this is like a lot of my experience was in the NSF, and you probably the NIH. So I don't want to kind of to say something which I'm not familiar with about NIH programs. So I stick with NSF kind of views. But I'm sure this is a similar trend is happening, right? And you can see more and more federal funding agencies starting to look for this interdisciplinary research and the convergence in research. And there's even more federal investment into the AI and the data science. And they build, and of course, like this seems like the national strategy. Think the AI and data science can transform many disciplines, and we need to be in the US, need to be in the leadership position. And that's why there's a lot of investment into this kind of areas. And to have this kind of interdisciplinary and convergence research, right? And how that is relevant to the UB. And I would argue, since actually this is one of the reasons actually attracted me to join UB, right? UB really has a broad expertise in many disciplines, right? This is something I just take a screenshot from the Wikipedia, we have 13, right, academic schools and colleges. And you look at the list, you can pretty much find all the major disciplines, and especially the healthcare, right? In about, there's a lot of units associated with the healthcare related research and practices. So how UB can tap into this kind of federal funding, investment, and the interest, right? And how can we leverage our own background and expertise so we can be known for our research. So this kind of the pretty kind of high level, right? So also for people who are now these days, everyone is talking about this AI. I also would like to give you a quick history about this AI. Really, the AI is not new, right? And probably some of you know this already. What I want to show you is, the AI has really been up and downs, right? And for 3 times almost, let's say 2 times up and down. Now this is our 3rd time is up, and hopefully we will continue to grow. And I like to point out, why this is we've seen this kind of trend, right? Because of in the first few cycles, in the first one, for example, right, it's really the early days of the computing, and it kind of inspired people's imagination. Think of AI can do everything, but quickly people realized, right, technology, computing, and the data, everything's not ready. So that's kind of the first crash of the we call the good old days, right, AI, and and then the second kind of the period, is the AI is starting to the expert systems, and with a lot of this handcrafted knowledges and the rules, and that is really the second kind of the booming of the AI systems, and it also quickly people realized handcraft rules knowledge, right, is very brittle, not scalable, and that is kind of shows you the second kind of the job of the AI. Now the last one is the recent ones. Now the AI seems like it continues to grow, and kind of give you a little bit of a historical perspective, right? Like especially in the healthcare areas, in the second period of the expert system. In fact, there's already an AI system called in identifying the organic molecules. And this was a system developed by professors from the Stanford University in like 1965, and basically it's kind of really based on the identifying the chemical structures, right? And build the histogram and set up some parameters, thresholding, and then they do some kind of identifications. And there's also some follow-up expert systems like MySim here, which is the first thing called the Dendro. I'm sorry, I should point out here. The first thing called the Dendro, right? MySim is the follow-up systems. Again, it's based on expert systems. And they were able to diagnose and recommend treatment for bacterial infections and blood clotting disease. So I want to bring this use cases here, right? So as you can see, actually healthcare kind of related the use of AI is leading the way, even in the very, very early days. And this has always been one of the most important use cases. Okay. So now let me shift to the modern AI. Why suddenly the modern AI kind of becomes it is today, right? So since I came from the IBM, I would like to point out that really, if people may not know all the histories about the AI, this is third AI boom started with an event, right? And at IBM, and when I was at IBM Research, and that's the IBM called the Jeopardy Grand Challenge, and IBM basically designed a system, right, to participate in the Jeopardy show, and to provide answers to this kind of unstructured questions. And the computer system has to understand unstructured natural languages and do all kinds of computation and reasoning and betting strategies and etc. And in order to give the right answer, and also has to compete with 2 humans with the right strategies. At the end of the day, the February 16th, and IBM demonstrated, and the IBM's AI system called Watson is able to compete with the 2 of the best champions in the final Jeopardy. And that really, again, wake up people's imagination. Now, if computer can understand the natural language and can reason and can compete as human, right, in such a complex games, what other things people can do. And that's really the wake-up call for the third of the current AI boom. And fast forward, right, since that moment, February 16, 2011, I was at IBM, and now industry is getting more interested into this concept, and there's more kind of innovations. And about 5 years later, right, another very big kind of moment in the AI is the AlphaGo, right? And this AlphaGo is the Go game, and now the computers can defeat the Go grandmaster. And that shows you not only about the computation, now scalability is all under control now. So the AI is able to solve this one of the most complicated games. Again, fast forward now related to the healthcare, right? It's the AlphaFold and the 2 in the November 30th, 2020. And AlphaFold 2 from the DeepMind Google, right? And that really demonstrates how AI can solve a 50-year-old grand challenges in biology. And that is a really, really transformative kind of the demonstration of what AI can do. And maybe this is only to know to some of the people, right? Not all the people, especially. And this is really the wake-up call, in about last year, November 30th, right, 2022, or now that's 2 years ago almost. The ChatGPT was released by through the OpenAI, and that has really educated almost everyone about the possibility of the power of AI. And today, when people talk about AI, most of people will immediately relate it to the ChatGPT. So now this is kind of a quick historical view, right? So let me give you a little bit of more insights about what is AI anyway, right? Because I'm sure you probably also heard of other terms like machine learning or data mining, and how are they related? If you read the newsletters or publications, right, and the people really use those terms seem like interchangeably, and sometimes you may just wonder, which one should I use? And let me give you some like a historical, a more like academic, a more precise, a little bit precise definition, right? But also give you a little bit of the relationship between them. And this artificial intelligence really is starting from the first AI kind of period, right? And it really is talking about the human intelligence exhibited by the machines. And when we say machines here, it's really about a computer program, okay? So this is really the original definition of artificial intelligence. And machine learning is something much narrow, and it's related to, because it cannot exhibit all the human intelligence. So the machine learning define the learning as a particular task. So you have to define a set class of a task, right? And also you need to define a performance metric. And the computer programs by learning doing this task, and this performance getting better. That is called the machine learning. So as you can see, this is a much narrower definition of the artificial intelligence in a sense, right? And the data mining is even kind of a narrower definition in a sense, Instead of focusing on the task, it's more focused on the patterns. And based on the data, can you automatically find the patterns? And that's the data mining, okay? And I drew this kind of a graph to show you the more or less this relationship. And of course, if you search online, you may see a slightly different pictures about this explanation. But I have my reasoning of this kind of a relationship, right? And I'll give you some citations. The AI was defined in the early 50s, and the machine learning concept was in the later 50s, and the data mining was later 80s. So that you can see this is kind of the definition-wise, and how it was coming along. And the related concept is called the artificial general intelligence, or the applied artificial intelligence, or weak AI, or stronger AI. The artificial general intelligence means intelligence that is really the more like a human, right? And that is called the general artificial intelligence, okay? And what is AI? What we are talking about these days actually is the applied AI, and which is a much narrower definition, which means that we always try to solve some specific task. Even ChatGPT by itself, for example, right? They cannot solve all the tasks like a general humans can do. So it is still kind of applied AI, or called a weak AI. And the Hollywood movie type of the stronger AI, I would still consider it's still many years away from us. Okay, and maybe there's some more optimistic view. Maybe think of in next 10 years. But for me, I still think maybe way more than 10 years. This is kind of my predictions here. But doesn't mean that AI will not be here, right? So I think the weak AI, like the applied AI, will just getting bigger and bigger and will solve many more interesting tasks. So now let me take a look, right? So how does the health science really benefit from AI? I think that's what all the audience here probably more interesting to know. And I want to start with some of the things which we are doing right now, right? And which is maybe it's still tangentially related to the health science, but maybe it can be quite related as well. And back to my kind of a few slides back, right? Talk about NSF interest in this interdisciplinary research and the conversion research. And so a few years ago, NSF really think that AI should US should lead the AI research, and but still try to anchor to some of the real use cases. So this kind of NSF started this program called the National AI Institute Research Institute program, right? It's a user-inspired AI research to ensure US will continue to be the in the leadership position. And in this kind of a program, that's kind of my role becomes a little bit more kind of I played a more critical role here, and UB really won this one of the National AI Institute program, and this is here I'm showing you all the 25 programs at this moment, nationally, and as you can see, some focus on the agriculture, some focus on the networking, edge devices, etc. Right, and it's also some focus on the education. And the UB is the only one nationally focused on the AI research for children with disabilities. Children with disabilities, I would consider this is a particular population, right? And that is maybe related to the healthcare related professionals as well. And and I can use another time and to talk about more about our research here. So we have a lot of the research around how can we help children with disabilities in terms of the speech languages and something related, okay, maybe it's adjacent spaces as well. So this is if anyone interested in this particular topic, and UB is the lead in this area, and it's just on the North Campus, right? And we are welcome people to come and to visit, and we will have a space in the Lockwood, just next to the across the Lockwood library door. Okay, and so now let's talk about the AI. How can we develop AI technology, right? And the recent advancement of AI is driven by three main kind of trends, right? One is the large availability of the data. Second is about the computing, and the third one is about the algorithms. And of course, computing and algorithms probably will not cover it today. And I'm going to talk about the data. The data plays a major role. And in particular, in this recent booming of AI, and the data from the computer vision community is really leading the way. And some of the most known data set, right, the ImageNet, is about the image, with tens of millions of images that has been humanly meticulously labeled, right, about the categories. And that is one of the data sets. So that's why you can see now the AI models can recognize dogs, cats, and very accurately, right? The second data set is the COCO data set. It's another larger scale data set, but that also with the humans annotations. As you can see, they carve out the humans, right, and all the objects. And this is very good for the object detections and the segmentations, and also some of the image captions, etc. There's another very large scale data set. Because of the availability of the data set, plus computing, plus the models, algorithms, and that really made the recent AI, all this advancement possible. And I think this is a good thing, right? Especially for the healthcare science, because in the past probably decades, and the digitalization is a trend in the healthcare kind of practices, and that digitalization effort has produced a lot of electronic data for the healthcare, and ranging from the the imaging data, right, like MRI, CT scan, X-rays, etc., right, and also some of the structured data, like the genomic informations and the protein structures, and of course, including other modalities of the data, right? It can be the voice, and also can be the text, like the electronic health records, right, and the prescriptions, the medical notes, etc. So now in the healthcare domains, you already have a lot of data, right? And of course, the computing, something you don't have to worry about, and the algorithm is something which we do, right? So it's all available now. So now the healthcare, like your practice, is the right time for innovations. So that's why we are all so excited to coming together, right? To think about how AI can help and to transforming the health science research. And the AI can help with the health science, right, to or the medical practice to improve the quality, however you want to define it. So quality can be some accuracy, right, and less time, and the productivity, and there's many, many things. And the high level is, you have a lot of data, right, and you also have your patient kind of the individualized informations. Now the challenge is, can we find this AI, right? What does AI should look like? So to help different use cases, be it diagnosis, prevention, treatment, prognosis, right, etc. So this is kind of shows you there's a lot of possibilities. But in order for this to work, we have to know what data do we have, right? What are the specific patient use cases, like individualized consideration we need to have in order for us to solve a particular type of challenges. Okay, so now I'm going to switch gear again, right, to show you a few examples from the current literature, right, and what AI can do, and also touch upon some of our work as well. And I will start from the kind of the data, right, because the medical data has so many different modalities, okay, and some image data, structured data, etc., right? So I'll start with the medical imaging data. So to see how AI for medical imaging, right, and what are the possibilities if you have medical images, and depending on the question you want to answer, and you can find all kinds of interesting solutions. And here is an example. For example, like diabetic retinopathy, right? So this is I call it DR. This is a complication of diabetes that will damage the retinal blood vessels, and so which means okay, the people's vision may get impaired or lost vision. And the early identification is very important, and because they can manage the diabetes, and this symptoms and disease may be less severe. And in the U.S., this some of the data I got from the references. There's 9.6 million people, right, in the U.S. living with the DR, and yet the doctors, right, and ophthalmologist, is only 20,000. So this is definitely some kind of issues here, and because you can take the images, and you can, as you can see, this is still going to be perfectly used of the AI, and indeed in 2016, like Google developed an AI system, right? It's based on a convolutional neural network called the Inception V3. This is something like a network. This basically is a kind of computer science, kind of the geeks terminology, right? About how to design the algorithms and how to use the computings to train it. But what's interesting to you is, if you can take the retina image, right? You can fit into this models, AI models, and then this can tell you, right, the healthy status of the retina. And it has been shown using this AI, you can improve the detection rate. The accuracy is 97%, which is on par with the professionals. And this is about the algorithm. Combining the algorithms, deploy the algorithms into the IoT or the devices, right, which has a limited power or computation constraints. And you can really produce some very innovative, low-cost solutions. And in this case, the Microsoft, right, they have a project called Iris. And this is kind of using the AI algorithm as shown in the previous slides, right? And deploy the algorithms into a smartphone devices. So now you can design a very portable device. Now anyone almost, right, with a very minimal training, now you can do this diagnosis of diabetic retinopathy very accurately. So this kind of shows you the combination of the AI, right? Deploying the AI into the smaller devices can really transform the healthcare practices. So this is one of the examples. And similar examples for can be do other things, like for example, another is skin cancers, right? Again, if you have the images, right, and you know what kind of cancers you want to detect. And once you have the data, again, you can train a neural network, right? And a similar network here as the previous one. And you can detect, and based on your use cases, are you only about the yes or no answers, or you want to be more fine-grained kind of the detections, classifications. So this is all possible, right? So this is something which also has been demonstrated, okay, and I list the references here. And this was published in the Nature, okay, in 2017. And so just kind of by simply through the by analogy, you can see, right? If you have images, be it the different kind of the CT scans or MRIs, right? And even some pathology kind of the images. And if you can formulate your problems and the AI is very good with this medical image understanding, and you can see these are all the things has been reported in the literature, right? And some of this is very recent, like 2022, and showed some of these results. So even though, I mean, this is still a lot of opportunities, so long as you can formulate your use cases and with the right imaging data, the AI can help. So this is one big category. Another category is not the images, right? It can be structured data, which is for example, like genomics. And the AI for computational genomics is another very kind of promising areas and for AI to make a difference. And here, for example, like how to use the AI to help to analyze the genome sequence data. And the Google has a project called the Deep Variant. And basically kind of using the AI technologies to help you to do the sequencing kind of work. And compared to the older days, the computation, and it is faster and more accurate. So this kind of shows another promise of using AI to solve a different kind of data input, right? Not the image related, but it's a structured data. In this case, it's a genome sequence data. And this is a kind of a detailed view of the project I just mentioned, the AlphaFold, right? AlphaFold 2, and for the protein structure prediction. And so this can be used for the drug discovery, for example, right? Again, if you have the protein sequences, which is the structured data, and by designing this something in the middle, which is of course very complicated AI algorithms and the steps, right? And Google showed, okay, this is and also possible, and to construct this right for protein structures, and you can predict this is the right structures. And this is it's can be transformative, right, for the drug discovery. And this shows how AI what AI can do. Okay. And now the last piece is about the large language model, right? Like a ChatGPT. And the ChatGPT, and since it came out, the large language model, and there's also a lot of follow-up work, and this is I'm highlighting a couple of them, right? One of these is the MedPalm, which is kind of how can, instead of feeding the general knowledge, right, like from the web to train the ChatGPT, instead maybe you can use the healthcare related medical information and fit into the large language model. Now the large language model suddenly becomes a health kind of search Q&A kind of engine. So you can answer all kinds of the medical related questions. And according to the research, right, and compared to the early days kind of systems, and this using large language model, there's a huge performance jump, and which is kind of also very new. Is kind of the papers of this last year, right? And it's also published in the Nature. And the recent trend of large language model, like even the ChatGPT, right, is not only about the text. Now it's also multimodality, which means that the AI model can simultaneously consider information across the modalities, like a text and the images or the videos, right? Because of in the healthcare, right, especially the surgeons, and when you do the surgeries, there's so many videos and you can take, and so now there's also a very recent work, right, and last year, and it's a lava mat, and from Microsoft, and how can you use the large language models to train both the text and together with the videos, and you can do some of this medical visual kind of understanding. And here, for example, right, and you can input in the images, you can start to ask the questions about these images. And here is kind of a demonstration from the paper, right? And you upload the image, you can ask what is the image about? And this model can tell you what is the image about, right? And you can have a further conversation. What is kind of abnormal about these images? And they can give us the reasonings. So now, as you can see, right, if such a capability is available, there's a huge productivity, right? And also helps the doctor-patient communications as well. And speak about the doctor-patient communication. And this is another project, actually, which is, I think Teresa Quadrant is on the call, right? This is something, and she kind of posted to me last year. And so I've been working on this project. And so I think we have some results, and we're happy to share some of this. Again, this is very early results, right? Again, to use the large language models to simplify the medical text, and so that the doctors can communicate with the patient better, or maybe provide us systems to communicate all the medical information to the patient with different level of literacy, right? And this involving some kind of vocabulary simplification and the sentence simplification, but yet you still have to make sure that the semantically the meaning is right. And so this large language model made this is also possible. And some things that we are still working on. So before I open up, right, I also want to kind of leave a few things here. Like, what are the challenges? So it looks like AI can do a lot of things for the healthcare, and I'll just give you a few samples. But there's still some major challenges I want you to keep in mind, right? The first one is the uncertainty. Yeah, even though I think AI is great, right? Yet AI sometimes can make mistakes too. Sometimes AI's result is not very 100% accurate. And yet in the healthcare areas, I think the accuracy is very crucial. So which means how do we balance this kind of applying the AI to solve the problem at hand? At the same time, you realize there's some kind of uncertainties. There's a couple of topics in the areas, and some of them I'm also working on as well. For example, one is the confidence calibration. So which means for the models you are producing, right? You need to calibrate your models. So the model needs to know, whatever I'm predicting, and the percentage of the accuracy should be percentage corresponding to my certainty of my results. And another is called the selective prediction. So which means that when I make any prediction through the AI, I tell you the uncertainties. And when I'm more or less confident of my predictions, I will tell you this is my predictions. If I'm not certain, maybe I should say, I don't know, right? The model should tell, I don't know. So this way, the human can be in the loop to make decisions. So that's why you don't have to entirely rely on the AI models. So it's AI human collaboration. So this is a topic called the selective prediction. Okay, this is something I'm working on, and if you're interested in this kind of topics, and please let me know as well. Another challenge is about the privacy, right? Because of the sensitivity of the healthcare data, and how do we maintain the privacy? And as I just mentioned, AI requires a lot of data to train the model. But the data, so who owns the data, right? Where do you store the data? And are there any sensitivities and the private information, etc.? So there's a lot of things related to the data privacy. In the AI areas, there's also a couple of interesting researchers. One is the federated learning, for example. They allows the AI models to be learned, right, to be trained in a distributed fashion, so the data does not have to be put into one central location. another technology is multi-party computation, which is a subfield of homomorphic encryption. This allows AI, right, to be working on encrypted data, which means your data can be encrypted and can be confidential, and the AI can work on the encrypted data and can still do the prediction. So this is some of the very exciting areas, okay, emerging areas, okay. Yet it's not mature yet, but it's kind of quite interesting. There's a lot of research need to be done here. So these are the few kind of challenges, right? So right now, even though there's many people talking about AI, really, I put the companies, right, who are benefiting from the talking about AI into these four categories, and each with different characteristics, right? The first one is the AI infrastructure companies like NVIDIA, right? The one who provide you the computation infrastructure, they get the benefit right now. And the second one is this vertically integrated companies, which has very concrete AI use cases, like Tesla, Apple, Amazon, right? They have very specific use cases. They also have vertically integrated, so they have the data, they have the use cases, they have their own customers. They get a benefit of the AI. The third category is the kind of startups, right? The tech startups. They show some very exciting innovations, even like OpenAI and Stability AI, and this is for the generative AI companies. Right now, even though they have a lot of excitement, they have not been fully materialized in terms of market values, okay, or the cash values. The last category is the companies with the domain-specific data for AI, right? Like for example, some of the healthcare providers, and that some of them get acquired by bigger companies, and the reason for them to be acquired is because they have the domain-specific data. So why I put these four categories? So I want to relate this to you, right? Like in the research domain, what do we have? For example, the AI infrastructure, right? As you heard of a couple of days ago, the Governor Hochul's announcement. So UB is considered being this like a potential the Empower AI hub, right? So we're going to have this infrastructure, which is something which we have, which we're going to have. So something you don't have to worry about. But as a healthcare science field, right, at UB, we are vertically integrated in a sense. We have the data, we have the use cases. So in a sense, we should be ready, right, to really get the benefit from AI. So this is something like all of us should feel very excited about the opportunities and the things we can do together. So in conclusion, let me give you just one more thing here. So because a lot of people talking to me, so how they can use AI, and what are the questions they should be kind of prepared, right, in order for you to really meaningfully engage some kind of AI conversations. So I come with this idea called the guide, okay? It's the guide model. I think when you try to work with the computer scientists or the AI researchers about your use cases, start with the guide model, and which is the 5 steps. The guide means, okay, it's the gather, understand, identify, determine, and execute. So what do I mean by this one, right? The gather. You need to gather the facts about your existing practices. What are the main pain points you need to find out, right? Understand. Once you identify the pain points, you need to also to explain to us, what are the current practices? What does the process look like? Because of the way you define your process may change how you're going to solve this problem, right? And the third one is identify. In the entire process, right, we need also to know what are the steps that can benefit from AI. And once you identify this one, then you determine, right, what is the investment strategy, right? Should you outsourcing, like you just kind of throw the problems over, right, for someone else to solve it? Or maybe you recruit some AI experts working with you, right, internally, in sourcing, or versus some kind of a collaboration, maybe working with people, right, together. So this you need to determine what I call the investment strategy, right? Finally is execute, and working, no matter which one, how you're going to do it, right? You need to do the execution. with the validation and the evaluation. So this is kind of I call it the guide model. This is something I coined as a term here. So hopefully this gives you the much more concrete framework to think about, right? If you say, hey, I want to use AI to solve something. So I would consider, can you explain to me, this is 5 steps, right? Or maybe at least the first 3 steps. Then together we can determine the last 2 steps, The last step of execution, right? That is where the AI researchers can jump in to do the work. Okay, so there's 15 minutes left. I have some examples to explain this guide model and using some self-driving cars to show you why different ways of this explaining, right? Different ways of modeling your business process. You may end up with different solutions. But I think I'm going to stop here. Maybe I can save the remaining 15 minutes for Q&A.
That would be great. Thank you, Jinjun.
Okay. Yeah. My recommendation is reach out, right, for collaborate. So, yeah.
Okay. Thank you so much. I've heard from a lot of colleagues via email and chat and also text messages how interesting all of this is when you present it. So I do have some people who have some questions that they would like to pose to you, and I don't dare try and translate for them. So the first person that has a question is Sandra Coleman. Sandra, do you want to explain to Jinjun your question?
Well, hello. Thank you so much for organizing this. I recently moved my lab from Carnegie Mellon to UB, and we do some machine learning, and we're a neuroscience lab. And I guess I've got 2 questions. So in my field, CNNs with backprop have given us a lot of insight in how actual neural networks in our mammalian models, we use mice, actually operate during perception. And I was very curious with your selective prediction on the computation side, do you have any ideas or looking to collaborate with how we could take what you're working on and actually see if that kind of confidence models exist in real neural networks?
Sure. Okay. This something probably takes a longer conversation, right? We have some work in this. Okay. Can you hear me?
Yes.
Oh, okay, cool. Yes, okay. This is something longer conversation, right? I do have some work on this space and I'm continuing working on this one, and so it has to be depending on, of course, your use case and what model you are using, right? This already is, in a sense, this is a selective prediction, and even the confidence calibration has been around for a few years now. There's some existing work, and we have some of our work as well. And but it's always have to be evaluated first, right, to see if that meets your need or not. If the existing technologies, and if it is, that's great. If not, then we can discuss, maybe the ways to improve it. Yes, please reach out to me, Sandra.
Okay, great. I'll send you an email. Fantastic. And then I have a second question that's more on logistic infrastructure. So we are honestly struggling a little bit with our server management, and I'm curious if there's a liaison or a contact person that I could meet with to better design our computing infrastructure.
Yeah, that's a great question. Yesterday, I just had a meeting with our CIO office, right, and the BRIS, and talking about this one. Yes, unfortunately, right now, okay, in the UP, this computing resource is a little bit of a scattered, right? And at this case, in terms of big computing resource, I know like a CCR, right, has one, CIO office has one, and the medical schools has one, right? And the fourth one is kind of scattered in every professor's lab, his own shop, right? Even my own, like computer science, where we have a lab here, we have quite a few servers, but it's not integrated, right? That's one thing. Second, they are not connected, right? And they are not known to people, and how to access and how to use it. It's also very opaque, probably it's more complicated, right? And hopefully through this like a governance investment, right? If this can be passed the legislature, and you really get the funding, and we can take a more holistic approach to manage our computing resources, right? Made it available. And Brice and I already had a first conversation. We both see the need to have a kind of in preparation for this new investment, right? And we need to have a better soft infrastructures, right, to make it available. So And you can reach out to me. I just can be a point of contact for now. And
Oh, fantastic. Because yeah, in the meantime, I mean, all of that is fantastic. But in the meantime, in the next 6 months, I have to publish papers and keep going. And so it's like, in some ways, it's a little scary to think, oh, in the future, there's going to be this great stuff. But how do I manage my day-to-day needs now is something that's very interesting.
right. So for some of the computers, I know the CCR resource. I have my own resources, right? When I first came here, I used my startup funding, bought a server, put it into the CCR as a
Well,
for
see,
sharing.
that's the problem though. I don't have
Yeah.
access to, I have my servers literally sitting here and they won't connect them.
Right. So I mean, something we can talk about, if we can collect more of this kind of use cases from individual faculties, right? It
Yeah,
can help
that's why
us.
I bring it up, just to
Right.
say, yeah, there's so much more we could do with a little bit of twisting, I think.
Right. And then we can come with a better strategies, what does the solution should look like, that way everyone feels like it's a right solutions for everyone.
Thank you.
Thanks,
Sure.
Jinjun. So
Yeah.
there's another question from Riley Engelhardt. Riley, are you still on?
Yes, I am. Thank you very much. How do you imagine AI being integrated into medical research with regards to personnel? Would individual labs or individual PIs have an AI expert on staff to help with their individual projects? Or would a medical school have a particular department of AI experts so that when a lab or PI has a problem, they quote unquote outsource it to that internal department?
Right. That's exactly I think the determinant, right? I don't have a good answer for you. And actually, yesterday, Jill and I also talked about this one, right? I'm also still kind of struggling to come with the right infrastructure, kind of organizational structures, insourcing, outsourcing, or collaborate, right? For example, UB has this IAD, as I mentioned to you, the IAD was set up at the campus level organization, right? It doesn't belong to any department, right? It doesn't belong to any school per se. And that should be a perfect, in a sense, perfect location, place for this consolidated kind of outsourcing or collaboration point. But this is what affects many, it's kind of, I think it's the organizational discussions. So I say right now, unfortunately, there's no easy answers, but what I can tell you is the leadership team is aware of this challenge, right? Like Jill and mentioned, Jill and Allison, right? And we will have conversations to think about, how can we best utilize our current investment, right? This organizational structures. Instead of every PI's lab, right? Get the funding, hire the postdoc, the researchers, find something in the AI, which may or may not be the best, right? Then you kind of repeated the investment, repeated buying different equipment, and also some of the knowledge cannot be shared. The best practice cannot be shared, which I don't think that's the best practices, right? The only thing that we need to address is, how do we make sure everyone feel like someone's not taking away my credit, right? My contribution, right? Yet still, that's a very collaborative spirit, and so willing to share some of your credit for people who helped you as well. So this something, of course, involves a lot of the human natures as well, but also involves the organizational kind of I would say the willpower, right? Hey, I think this is the right thing to do. We should institutionalize. Let's do it, right? And there's a lot of the discussion need to be happen at the top level as well. But of course, if people, right, like people here, you feel like, hey, strongly certain model work best. I think please share this message with Jill or myself, right? And then we can bring your voice, to the leadership discussion, right? Say, hey, this is what the people ask for it, we should do it this way.
Thank
Please,
you.
yeah, to surface that kind of concerns and your solutions, to the leadership team, please.
All right, thank you very much, my friend.
So we have another question from Dakshesh, who actually has a very good question, who's posed it, but Dakshesh, are you still here?
Hi, I'm here. I'll just read out the question. How do you plan to evaluate the performance of these models? Because in health science, trial and error is like usually not an option, right? Unlike other fields of AI, like autonomous driving. And I have a second question also. Does UB allow keeping decentralized servers to store confidential information? we dealt with some problem regarding knowledge software that is used for human behavioral analysis, and like how the data gets backed up on the UV server, and then isn't that making it more vulnerable because it's all in one main server, one location?
Okay, thank you. Okay, so let me answer the first question first, right? The validation. And I mean, like AI model was developed with some very rigorous methodology of validation, right? And so it's a matter of like, do you have the data for validation or not? And of course, in the healthcare, as I mentioned, it's even more critical, right? So first, you can pure data-driven validation, but you also need to have the doctors, right, like yourself, right, working with the models to do the in-field validations as well. And of course, you also need to make sure that the AI model is not 100% accurate. Like as I mentioned earlier, right, this is uncertainty management. You need to be aware of the uncertainties and manage the uncertainties. So I think that's kind of the general answers to your about validation questions. The second question concern about the data privacy and the storage, right? And there's already some good practices, how to build the infrastructure that is HIPAA compliant. So it's safe to store the data. For example, like the box folder, right, we're using right now. I think it is HIPAA compliant. You can save your data. Like I think you can save there, right? And also some of the cloud providers, and I think the IBM cloud, I know, and I'm sure Amazon these days, and probably Google too. They all have the HIPAA compliant cloud storage too. And of course, you mentioned this is a kind of a point of a failure, right? If you put all the data into one location, central locations, and then if some hackers, unfortunately, hacked in, that can be like a 1 point of a failure, right? That could be detrimental. Indeed, that's the case, right? That's about your strategies. Do you want to do the distributed storage or you want to do the centralized? There's also pros and cons, right? There's no perfect answers to this one. And there's also like a corresponding, that's the kind of, I mentioned the privacy preserving computation, right? Like the multi-party computation, right? And this is like a federated learning. It's all geared towards a distributed kind of data storage as well. So you don't have this a single point of failure kind of concerns. But there's no perfect solution. There's some good best practices and that we can adopt, right? And if UB becomes this AI hub, right, we will adopt those practices, so that way the data storage will not be a major concern.
Thank you.
Make sense?
Yeah,
Okay.
kind of understood it. Thank you.
Sure.
Jinjun, one last quick question, hopefully. We do have a question as to, can you mention any examples that you can offer right now of work that you're doing across the health science schools already with any groups, or is it just all in conversation at the moment?
Oh, yes. Okay. We already have it. Like it's one I work with Teresa, for example, right? Like on this text application. That's a project I quickly showed one slide, which is not fully developed yet. It's some kind of early results. So we are working on this project already, right? And also with Tim, right, on his CTSI proposals, we are already working on already submitted proposals. But I mean, Jill, right? We are working on other proposals. And we're also working with Peter, right? Peter Kim, and he's a new faculty in the medical school, and we just submitted upper H proposals on how to develop basically medical imaging related analysis to help the surgeons to see something surgeon cannot see, right? So there's already something going on, and this, of course, is I'm only one person here, and through the IID, right, I like to have more affiliated faculties join this effort, right, willing to listen to like people on your side about your use cases and willing to collaborate. And this takes some time to institute the best practices. And I hope more and more people, feel the benefit, they can join this kind of movement.
Thank you. Dr. Quatrin?
Hi, Jinjun. Thank
Hey.
you. Very interesting as usual. I just wanted to make a point because it is true that as physicians, we don't really like trial and errors. But I want to point out about the diabetes retinopathy, something that happened to me. A long time ago, we were doing a clinical trial where it was essential to look at any changes in the eyes. And our patients, as well as patients in another 10 centers in the US, were examined by board-certified top ophthalmologists that called the exam negative. But at the same time, 7 field pictures were collected, which that's why it's the best application for AI and image resolution. And all of a sudden, I was the PI on the project. I get this alarm call that the 7 fields are showing some signs that there was progression. So in the hands of the best ophthalmologist with a dilated exam, which I certainly don't do in my patients, nor I am an expert ophthalmologist, that was missed. So in a way, in medicine, we think that we have it all set up and all precise and all proof fail, but we don't. So I think without, with the principle of first do no harm, there are things that we can try to do to see if we can do a better job of coupling the human intelligence with the AI, I think.
Yeah, thank you, Teresa. Yes, definitely. That's a very good, well-articulated use cases in a sense. Yes, and there's a lot of things we can do together, and also AI can help, right? Because the doctors has a lot of, let's say, time constraints, right? Some things maybe but just cannot, just didn't. Maybe at that moment of time, you didn't cover it, right? The AI can be a good assistant, for physicians as well.
And perhaps sometimes we don't use the high tech. Say in the ED, in the pediatric intensive care, in the intensive care unit, in the neonatal intensive care unit, we may not be using that high tech in a way that combined or get all the data that would allow us to prevent a certain event. So I think if we put our heads together to the point that Jinjun said, of talking about things, we might come up with ideas that, don't be afraid to give an idea to Jinjun, because I thought, maybe he's going to think that this idea of looking at the plain language and trying to use AI for better communication in the clinical arena and in the research arena, maybe I'll think, this is not a good application. But if we put our heads together, if you put your heads together, I think we can come up with some additional ideas.
Yep, definitely, yes. And just trust me, every conversation is a good learning experience for me. So I learned a lot from all of you.
Well, we appreciate the fact that you're having so many conversations across campus, because I can tell you that from my experiences, you couldn't be any more collaborative and open to discussion than you are. And for that, we thank you. I hope that all of you enjoyed this today. I found it extremely informative. I think that there's so much potential. We're fortunate to have Jinjun here, and I hope that you can all join us on the 27th. The AI in Health Symposium already has great registrants and posters that are coming in, and I'm excited to say that they show a diversity of disciplines across all of our health science schools. So we're excited to collaborate, and thank you, Jinjun, so much for taking the time to do this today.